everybody, this is Miss Bufford, and in this video, we're going to talk about physical and chemical properties and changes. So in this video, your learning goals are to be able to give examples of physical properties and changes, be able to give examples of chemical properties and changes, and be able to explain how chemical changes are different from physical changes. So first, we're going to talk about physical properties and changes. Physical properties are those properties that can be observed or measured without changing the composition of matter. And physical changes are those changes that affect the form of a substance, but they don't change its chemical composition. So we might change the shape or the size of something, but we're not going to change the identity of something. So let's talk about some examples. Examples of physical properties would be like the state of matter that something is in, size, the shape, the volume, the density or mass. It could also be things like malleability, which is the ability for something to be hammered into a flat sheet, ductility, which is the ability for something to be pulled into a wire, luster, which is shine, brittleness, which is actually the opposite of malleability. So if we were to smash something with a hammer, it would break in a lot of little pieces if it was brittle. And then viscosity, which talks about or indicates the thickness of a liquid. And we're actually going to talk a little bit more about viscosity in a later building block. But some examples of some physical properties, if we're looking at malleability, ductility, and luster, aluminum fits, all of those properties really well. So aluminum has malleability, so it can be hammered or flattened into a flat sheet. It can be stretched into a wire, and it's got a little bit of shine, a little bit of luster to it. So aluminum is just a really good example of those three properties right there. Some examples of physical changes would be cutting paper. So if I had a sheet of paper and I cut a shape out of it, I'm changing the shape or the size of that paper, but it's still paper. It's still identifiable as paper. Separating mixtures is another, or the techniques that we use to separate mixtures are other examples of physical changes. So when we separate a mixture, we're actually taking advantage of the differences in physical properties of the components of each mixture. Changing from one state of matter to another is also a physical change. This is one that some students tend to confuse with a chemical change sometimes, but it's actually just a physical change. So an ice cube melting into liquid water and then maybe being heated and turning into a vapor is an example of a change in state that's a physical change. So it's still H2O, the chemical formula stays the same whether it's a solid ice cube, whether it is a liquid or a gas. And the only difference there between those states of matter is the amount of energy that the particles or those water molecules contain. And we'll talk about that again in another building block as well. Breaking, bending, folding, or stretching something, these are all physical changes. For example, we have this wine glass right here. It's slowly being smashed into smaller and smaller pieces. And even though at the very end we've got a bunch of little tiny pieces here, they're all glass. It's still glass, it's just in tinier pieces now. So those are all examples of physical changes. All right, so chemical properties and changes. Chemical properties are those properties of a substance that become evident when the substance undergoes a chemical change. So we have to have a chemical change in order to be able to determine what these chemical properties are. And so we have to do some experimentation to determine chemical properties. We can't just look at something and be able to say that, hey, that looks flammable. We actually have to try to light something on fire before we can say it's flammable. So some other examples, aside from flammability, would be a substance's ability to react with another substance. Okay, so we have to do some experimentation there to figure that out. Chemical changes, these occur when a substance combines with another substance to form one or more new substances with new chemical properties and physical properties. Or it could occur when a substance decomposes into two or more new substances. The key here is that we're starting with one thing that has its own, or we're starting substances that have their own identity, their own chemical and physical property makeups, and they are changing and becoming something else that has a different set of chemical and physical properties that are unique to that new substance. And an example of this would be the formation of table salt, the stuff that we put on our food. So table salt's formula is sodium NaCl, sodium chloride. All right, and so we've got sodium metal here. And sodium metal is a very reactive metal. If I took a little tiny chunk of this and I threw it into a beaker, it would burst into flames and spark and race across the top of that water until the reaction was complete. And so it's a very violent reaction. It reacts very violently with water. And so this is definitely not something that you want to put in your mouth. You could cause yourself serious damage. And the products of that reaction are definitely not something you want in your mouth either. So sodium itself is not something you want to ingest. And then chlorine, right here, you can see it's this yellow colored gas, is actually something you don't want to be breathing in. It can cause severe, lethal lung damage. And actually this was used in something called mustard gas to poison people a long time ago. So this is definitely not something that you want to be breathing in or putting in your body in any way. So when these two things are in their elemental form, they're definitely toxic for humans. But when they come together and they react chemically with one another, they form table salt. And table salt is essential for life. We have to consume salt in order to maintain the biological processes that keep us alive. So salt is really important for us. But this is a really good example of how different the chemical properties can be from, a couple reactants to whatever product they might make. Okay. All right, so how do we tell if a chemical change has taken place? So there's some telltale signs that we can look for that will tell us whether a chemical change has taken place. One of those is a color change. So did you observe something changing color? The other is a temperature change. So if we're not really necessarily trying to heat or cool anything, but we mix two chemicals together and the reaction either gets really hot or really cold all by itself, then that's evidence right there that a chemical reaction is taking place in your container. The formation of a solid or precipitate in a reaction. So sometimes we might mix two solutions and they form a cloudy substance. And that cloudy substance is actually the formation of little teeny tiny microscopic solid particles that are forming between the ions in those two solutions. And so that is actually a chemical reaction. It's evidence that a reaction has taken place. And the production of gas bubbles. And it says sometimes here, and so what I mean by that is we're not boiling water and thinking that's a chemical reaction, because there are times when we produce bubbles, but it's not actually a chemical reaction. I'm talking about, if you mix a couple chemicals, like let's say we mix vinegar and baking soda, and that actually produces carbon dioxide. And so that production of carbon dioxide would be a piece of evidence that a chemical reaction took place in that, but not necessarily when we boil water, because the bubbles that are produced there is just that liquid expanding into a gas because it's absorbing a lot of energy. So the next one is that changes in chemical properties. So just like our example with the table salt and the sodium and the chlorine, we mix sodium and chlorine, two things that are toxic to us, and we produce something that is essential for us to survive. And then, maybe in another reaction, we mixed two things that were not flammable, but we produced a product that was flammable now. So are we producing something that has its own set of chemical properties? And then a change in smell is also another indicator that a chemical reaction has taken place. If you have ever had rotting food in your kitchen and you've been able to smell it, smells pretty bad, and you just gotta get rid of that. So that's a chemical reaction. That's decomposition of whatever's decomposing in your kitchen. And then baking food. So if you're baking cookies, the smell that fills your house when you're baking cookies is the product of a chemical reaction that's taking place in your oven. And then some reactions, when they occur, give off light. So the production of light is another indicator that a chemical reaction has taken place. So let's just go ahead and look at some pictures, and we're just going to kind of talk about the evidence that we see in each one of these pictures for a chemical reaction. All of these represent chemical reactions in some way. So let's take a look up here at these leaves. In the fall, when the leaves change color, there's actually a chemical reaction that takes place inside those leaves and causes this color change. And so our evidence there would be the color change. Then we have some rusty nails right here. And this would be, we've produced a new substance here, so our nails, they're no longer that gray, that dull gray color of iron. Now they're this rusty, rough, brittle red substance. So that has a new product with its own chemical and physical properties. So right there, that's a chemical reaction. This one right here, we've got the production of bubbles. And if we assume that we have dumped this purple liquid in that graduated cylinder into this Erlenmeyer flask to cause this reaction, then we can also say maybe color change for that one. When we cook eggs, we're causing a chemical reaction. We're causing the proteins in that egg white to denature, and they're changing from a somewhat translucent, gooey substance into an opaque, white, rubbery substance. So that's evidence of a chemical reaction right there. We've got a time lapse here of these 3 Erlenmeyer flasks. And you can see that over time they're changing color, so that's evidence that there's a chemical reaction happening in there. Then we've got these logs that are burning, so they're giving off light, they're giving off heat, they're producing new substances, so this wood is turning to ash, and we can't see it, but it's also giving off carbon dioxide and water vapor, and you can see smoke leaving, so there's lots of evidence there for a chemical reaction. And then these beakers right here, these little short beakers, if you'll notice there's a clear liquid inside there, and then we're adding another clear liquid, a solution, and these two solutions contain different types of ions, and when those ions come in contact with each other, they bind together, and if they're not soluble, then they form a solid. They kind of stick together and they don't want to come back apart. They don't want to dissolve back into that solution. So those are actually little teeny tiny powdery solid particles that are forming in both of these solutions here. And so that's evidence of a chemical reaction. When a banana ripens, as it ripens, it changes color. That's evidence that there's a chemical reaction going on in that banana. This would be color change, so evidence of a chemical reaction there. The elephant toothpaste is a really good example of bubbles being produced. So we put the soap in that reaction right there because it makes it look really cool, but it also allows us to see all the gas that's produced during that reaction. These lizards right here, chameleons, they change color to blend in with their background, whatever's around them, and they use hormones. So that's a chemical reaction that takes place inside their bodies to change their bodies' different colors. And then here we've got a silver spoon that's been left out, and it's reacting with the oxygen in the air and forming a tarnish layer over that silver spoon. All right, so these are all examples of chemical changes, and the way that we can tell the difference between a chemical change and a physical change is that if it's a physical change, we still have the substance that we started with. But if it's a chemical change, we'll notice that we have a brand new substance that has its own set of new chemical and physical properties. I hope this video was helpful. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.